Hello, welcome to my controls project. I'm Andre, and this is just the part where I demonstrate that I've built it and it functions. I just have it mounted on my computer here. You can see I also used just a ball, like a glass ball, as a weight. This is just test one, the sensor test, if the camera can focus. There we go. All we're doing here is reading the output from the encoder that is behind the Arduino, or it's not a branded Arduino board, but same function. As you can see, I'm lifting the arm, and we should see a corresponding angle change. Unfortunately, the scaling was off by quite a bit, so it goes from roughly negative 60 degrees to a little over 0 degrees, which we can see right here, but it looks like it's a much smaller shift in angle. But regardless, there's that part. And I give it a thumbs up. Alright, moving on to part 2. This is the logging test. We're just seeing how the serial plot application outputs data. And there you go, 4 sine waves for each 4 channels. Alright, now we're moving on to the slightly more fun parts. The ESC, or speed control test. We're arming it, and it calibrates, which does take a while. Plays its little down arpeggio, or up arpeggio and down arpeggio, when eventually it finishes. And I started it at a value of 20, even though the instructions recommended 50. I just wanted to see what a low value would do. No, not much. That was a value of 50, and I think I go up to 75 in this run. And if we look at the monitor, yeah, that's 75. I played around by constantly putting in new values, but there you go. And finally, this is the Mac Daddy, so to speak, of the tests. The test of the actual PID controller. So you can see I messed with the proportional, the integrator, and the derivative gains. I set them to 1, 4, and 0.4 respectively. And this was what produced more or less the best results. I tried tuning it for about 30 minutes, and it was very hard not to get it to freak out. So as you can see, it always tried to tend toward oscillatory motion, and I didn't like it after half an hour of trying. But anyway, that wasn't the point of this test. It does work. I did get different reactions with different settings. And finally, this is just a little bit of extra for part B of the last part of this this part of the project. So here we wanted to see how it reacts to a zero angle, zero angle of difference from one time step to another. And we can see that eventually it just cuts the throttle completely into the negatives. So if I start letting it go, it takes the I value a little bit of time to chill it out, and then it returns to its classic oscillatory motions. This was with the default PID values. Alright, well that's the video. Hopefully that presented everything well enough, and thanks for watching.